Good morning, good afternoon, wait. Good morning, good evening, good afternoon, whatever the case may be. We are back and better than ever, and we are indeed so fancy. I felt obliged to go over section B of review test number 3 because for the most part it was a bit of a disaster. So let's do this, shall we? Shall we? Okay, there's my pen. All right. So, number 8, line L1 passes through the points P248 and Q454. Find PQ. So, PQ equals, please write it in vector form, not in coordinate form. So, 4 minus 2, it's the Q minus the P, so that's 2. 5 minus 4 is 1. 4 minus 8 is negative 4. Bam! And if you wrote it like this, a couple of you did, you get 0 credit for that. That is a coordinate. This is a vector. Please don't do that to me. I do not want to throw myself off the balcony. I almost did. Got it? Good. All right. Hence, write down a vector equation for L1 in the form R equals A plus SB plus SB. So, L1, ready for this? R equals A plus SB. A is any point on the line. It could be P or it could be Q. So this first one could be 248, which I'm going to use. Or instead of 248, you could have also used 454. Plus S times the directional vector, which we just found, 2, 1, negative 4. No big whoop. Bam! Stylin'. Okay. Line L2 is perpendicular to L1 and parallel to this. So line L2 is parallel to this. And P is an element of the integers. Find the value of P. Well, if they're perpendicular, then the dot product of their directional vectors is 0. So we would take the dot product of this guy and 2, 1, negative 4. So we would say 3P times 2 plus 2P times 1 plus 4 times negative 4, and we would set that equal to 0. So 6P plus 2P minus 16. There were way too many of you who said 4 times negative 4 is negative 8. Very unhappy. So 8P equals 16, which means P equals 2. Yes, easy points there. Given that L2 passes through 10, 6, negative 40, write down a vector equation for L2. So for L2, we would have R equals 10, 6, negative 40, plus, and some of you put S again. Once we're in one big giant problem, so don't use the same parameter as you did in a previous vector equation. So I'm going to use T times. Now what direction is it in? What direction is this in? Well, all you have to do is replace P with 2. 3 times 2 is 6. 2 times 2 is 4. So it would be 6, 4, 4. How about that? All right, so we're done with that. Given that lines L1 and L2 intersect at point A, find the x coordinate of A. So this vector and this vector intersect, right? Now remember, another way to write R is x, y, z equals those coordinates. X, y, z equals those coordinates. So up here I have x equals 2 plus 2s. Well, if that's true, it must be equal to 10 plus 6t. My y's must be equal. 4 plus s equals 6 plus 4t. Mackenzie's going, yay! 6 plus 4t. And you don't have to necessarily use this one, but it might be a better fit. 8 minus 4s is equal to negative 40 plus 4t. Yes, 4t. Now this works out well because I can take this guy minus this guy and the t's drop out. So that would work wonders. So I don't need this guy. I don't need him. 4 minus 8, negative 4. S minus a negative 4s would be s plus 4s, which would be 5s. And this would equal 6 minus negative 40, which is 46. And 4t minus 4t. Michael Latanzi has stepped into the room, so we're going to have to ask him to come back later. I'm sorry, Michael. I got another 10 minutes or so. Good? Good. All right. So 6 minus a negative 40 is 46, and then 4t minus 4t is 0. So 5s is going to be equal to 50, which means s is equal to 10. And all I need is the x coordinate. Well, with s, x equals 2 plus 2s equals 2 plus 2 times 10, which is equal to 22. Done, 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 done. Next. This is the one that killed me. This killed me, people. This killed me. Easy money right here, and way too many of us miss this. The following diagram shows the graph. It's a sine curve. A sine bx minus c plus d for 2 to 10. For 2 to 10. That's important. 2 to 10. There is a maximum point for 12 and a minimum point at 8, negative 4. Use the graph to write down the value of A. A is our amplitude. It is the distance from the principal axis to the A max or A min. So the principal axis is going to be about right there. Not about right. It's going to be right there. Right there, because look at this. Here's one cycle. Yes? That's the principal axis. And it's halfway, well, then you just ask yourself for the amplitude, what's the distance from the principal axis to the top or the principal axis to the bottom? It's also halfway, the amplitude is halfway between the y coordinates. So 12 minus a negative 4, that's a distance of 16. Half of that is 8. It's 8. A is equal to 8. C, that's the horizontal shift. Yes? Horizontal shift. So how in the world do we think about this? There's lots of ways. We're completely symmetrical with this sine curve. Okay? So if from here to here, if you look at the x-coordinates, I have an x-coordinate of 4 and an x-coordinate of 8. This x-coordinate is going to be 6. Yes? And if from here, 4 to 6 is 2, from here to here is also 2. Yes? And if this is 4, if I go straight down here, this corresponds with a 2. Why is that so important? Well, clearly this sine curve has shifted up. Yes? We're used to the sine curve being on the x-axis and looking like this. Well, this is, the starting point is where the sine curve is equal to 0, which is equivalent to right here. Yes? So if this goes down, it had to move to the right 2 units. Therefore, my C is 2. Yes? Okay. And then how many units? D is the vertical shift. How many units did the original sine curve shift upwards? Yes? How far up is the principal axis? Well, clearly, if from here to here is 8, from here to here must be 4, because from here to here is 4. It's symmetrical. So this must be 4. Easy points. Too many of you all missed that. Okay. B equals 2 pi over 4. Well, we know the period is equal to 2 pi over B. Yes? 2 pi over B. Okay, well, what's the period? The period is the distance, how long it takes to cycle from here to here. Or you just subtract the endpoints of the x-coordinates. 10 minus 2 is 8. So you know the period is 8. So 8 equals 2 pi over b, which means that 8b equals 2 pi, which means that b equals 2 pi over 8, which is equal to pi over 4. Done, 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 done. Find f prime of x. Well, first we need f of x, okay? So even if you've messed up a and b, if you use those values and set them equal to one another, if you use those values and take the derivative, then you're still fine. So this would be 8, yes, sine, they gave us b, pi over 4, times x minus 2 plus 4. Derivative, f prime of x. We have a coefficient. It goes along for the ride, 8. Now we have a chain rule, chain rule, chain rule. Chain rule is derivative of outside times the derivative of the inside. So the outside function is sine, and the derivative of sine is cosine. So it's cosine of pi over 4 times x minus 2, yes, times the derivative of the inside. The inside is pi over 4 times x minus 2. Well, if you were to distribute that, which you can, pi over 4 over x minus 2 pi over 4, we don't even care, about 2 pi over 4 because it's a constant. And the derivative of a constant is 0, yes? So it's just the derivative of pi over 4x. Well, that's equal to pi over 4, yes? Just like if I had y equals 2x, the derivative of y equals 2x is simply 2. It's simply 2, right? It's the coefficient. Well, the coefficient of pi over 4x is, help me, pi over 4. So now I clean this up. 8 times pi over 4 is 8 pi over 4 or 2 pi. So I get 2 pi cosine of pi over 4 times x minus 2. And if I see one more plus c after a derivative, I am throwing myself off the balcony. It's over, 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 over. All right, D. At a point r, the gradient is negative 2 pi. Find the x-coordinate of r. The gradient. How do we find the gradient? We use the derivative, because the derivative is the slope of the tangent to the curve. The slope of the tangent to the curve. Well, we're trying to find the value of x for which the gradient is, or the slope is negative 2 pi. So we just say negative 2 pi equals 2 pi cos pi over 4 times x minus 2. How about them apples? Looky, looky, these cancel. Now there's a 1 here. It's like you're dividing both sides by 2 pi. So I have negative 1 equals cosine of pi over 4 times x minus 2. Okay. Now the problem is this cosine. But if I take the inverse cosine of both sides, this cosine goes away. So the arc cos of cos is equal to pi over 4 times x minus 2. Okay? And that's going to be equal to the arc cos of negative 1. Well, what does this mean? Well, it's asking, where does cosine equal negative 1? Cosine equals negative 1 at pi, right? So pi equals pi over 4 times x minus 2, yes? So I'm going to divide both sides by pi over 4, by pi over 4, yes? And pi divided by pi over 4, I can't believe I'm going to do this, is equal to pi times 4 over pi. That equals x minus 2. Look how easy this is. Kapow. 4 equals x minus 2. 6 equals x. Bam. Done. Not so bad. Not as bad as you thought it was. All of you can do that. Every single one of you. Last one, number 10. Okay. This was actually easier than you thought too. Let f of x equals 1/4 x squared plus 2. The line L is the tangent to the curve of f at 4, 6, right? So right here, you know, maybe you need to draw it or something because you guys were just, I don't know, you panicked. You panicked. So this is what we're talking about, this tangent line right here. And that is the coordinate 4, 6, okay? Find the equation of L. Well, L is a line, and to find the equation of a line, we need a point. Bam, we have it. We have point on the line is 4, 6. Hoorah! And we need the slope or the gradient, yes? How do we find the gradient? We take the derivative because the derivative gives us the gradient of the tangent to the curve, the slope of the tangent to the curve. And the derivative of f of x, some of you all took the integral, I just don't know what I was going to do. The derivative of 1/4 x squared is 2 times 1/4 is 1/2. It's 1/2 x. It's 1/2 x. Yes? Now, I'm not sure what's going on here. A lot of you said, oh, so the slope is 1/2. No! It's 1/2 x, where x is the point of tangency. Yes? It's the x-coordinate of the point of tangency, which in this case is 4. So I need to find f prime of 4, which is 1/2 of 4, which is 2. So my gradient is 2. And now the equation is L, the equation of the line L. Let me do it down here. Okay, this is the line L, would be y minus 6 equals 2 times x minus 4. And you can actually leave it like that because they don't say to put it in any particular form. But it might help that you say, I mean, if you wanted to simplify it, y equals 2x minus 8 plus 6, y equals 2x minus 2. And there you go. Find the area of the region enclosed by the curve of G. Oh, here's G. G equals this, and this is the curve of G. Yes? Yes, is that right? Oh, okay. Well, here's the thing. This curve was not this curve up here, but I just used it as an example. Okay, so you could see about the tangent because this curve is G. Okay, it's not F. Okay, this is G. So they're asking us to find the area from here, sorry that it's not straight, to here. All this area right in here. And most of you were okay. You said, oh, okay, so that's just the integral from 2 to 12 of 90 over 3x plus 4 dx, which is of the form 1 over 3 ax plus b. And remember, the integral of 1 over ax plus b is 1 over a natural log, absolute value, ax plus b plus c. Or you could use u substitution and do this. U equals 3x plus 4, du equals 3 dx. Okay, so you could have done that. Either way, this is going to turn into 90 times the integral from 2 to 12 of 1 over 3x plus 4. Factor out the 90, the uninvited relative nobody likes, right? So that's 90 times, I'm going to use this formula, 1 over a. My a is 3. So 1 over 3 times the natural log, the absolute value of 3x plus 4. There's no plus c because it has bounds. I'm going to evaluate it from 2 to 12. So let me just simplify this. 90 times 1/3 is 30. Yes, it is 30. So this would be 30 natural log. This is positive, the 12 and the 2, so I can forget, I don't have to worry about absolute value anymore. So that's 3 times 12 is 40 plus 30 natural log of 10, which equals 30 times natural log of 40 plus natural log Oh no, this is minus. Why did I say plus? Because I'm an idiot. This is minus. Minus natural log of 10. So this would be 30. Rules of logarithms, natural log of 40 over 10, which is 30 natural log of 4. So this area right here is 30 natural log of 4. And C, you guys got so uptight. It's so easy. C, the graph of G is reflected in the x-axis to give the graph of H. Draw a sketch. Please, please just draw a little sketch. Yes, here's X. This is reflected, so it's going to look like this. Something like that, right? From 2 to 12. Okay, so we have that. And this is H, whatever. Okay. The area of the region enclosed by the lines L, okay, well, where's L? L is 2x minus 2. So it's something like that, right? X equals 2, so right here. X equals 12, right here, yes, is 120. So this is 120, right? Find the area enclosed by the lines L, x equals 2, x equals 12, and the graph of H. Well, this flipped over, it's still going to go only from 2 to 12, yes? And we found this area here to be 30 natural log of 4. Well, it's still 30 natural log of 4. It's an area. It's positive. So the answer was simply 30 natural log of 4 plus 120. That's all you had to do right here for C. Very simple, very easy. I think you guys just panicked. I wanted to do this for you to show you how easy it is. Oh, so easy. Hope you enjoyed it. Let's see if we are still fancy. Want to? Let's see if we're still fancy. Yeah. Are we? Are we? Huh? We fancy? Oh, yeah, we fancy. That's right. But this ain't so fancy. You the bomb diggity? Get on it. We are out.